Welcome to Study Loop.
So this question is about sodium chloride and calcium chloride, and that both of these can be used in de-icing. Now, if we have a road surface which contains calcium chloride, and then we add sodium chloride, what happens to the solubility of the calcium chloride? Okay, well, we're going to have to think back to Le Chatelier's principle. Recall that for the solvation of calcium chloride, what we're thinking about is calcium chloride, right? The solid in equilibrium with dissolved calcium chloride or calcium 2 plus ions and 2 chlorine ions, anions to be specific. And if you recall, if we add more starting material, that's the left-hand side, we push the reaction forward, right? That's Le Chatelier's principle. If we increase the calcium chloride, the equilibrium shifts to decrease the calcium chloride. It's sort of like for every action, there's an equal and opposite reaction. We make calcium chloride go up, the reaction makes it go down by pushing the reaction forward and consuming calcium chloride. Okay, so therefore it stands to reason that if we add, say, chloride or product, this would work for calcium as well, so add product, then the reaction moves in the reverse direction, right? Because if we add chlorine, it wants to resist that change, and so it's going to consume chlorine by going backwards. So when we add sodium chloride, that is equivalent to adding Cl minus chlorine. And if we add Cl minus, what direction is that going to push the reaction? In the reverse direction. Okay. So does that represent an increase or a decrease in the solubility of calcium chloride if we're pushing in the reverse direction? Well, we're talking about going from dissolved to not dissolved, right? Which means then that the solubility decreases. Because by adding sodium chloride, we are adding Cl minus, and by Le Chatelier's principle, this would shift the equilibrium for the solvation of calcium chloride backwards. Which represents decreased solubility.